So you took Dewey's ideas as a basis, and then what encouraged you to create the first version of your framework?
Well, the problem was, it's the same problem we have today. The question is, okay, even if we can define what the strategy is, actual work has to take place. Okay, now you have to begin to do some actual architectural engineering work. So you can find the same thing in engineering and manufacturing as you can find in architecture and construction. So I was doing a lot of work by that time. They'd moved me into a large account. I had the Western Region staff responsibility for all the planning programs, and so I was doing work with clients basically in those days, and a lot of aerospace out in the Los Angeles area. So the question is, how do you actually do the actual work of it? Now I had to get definitive about what the other models looked like. So then I was doing a lot of work with airframe manufacturing and with architecture and construction. I had my friend from architecture and construction. So I just began to see what the models looked like. They had to, in manufacturing, they would call it the customer requirements. Gary Larson, the architect, would call it the architect's drawings, row 2. Then you transfer from row 2 to row 3. Gary would call those the architect's plans. Now you have to design the building. Defining the concepts is not designing the building. That's just defining what the owners have in mind, what they want to do with it conceptually. So then you have to understand how to design the building, because you have to deal with pressure per square inch and wind, and you have to deal with earthquakes, and you have to deal with pumping water up. It's the weight of the water, how far you can pump things up. You got to actually design the building. That's row 3. And manufacturing, we call that the as-designed representations. So you got the customer requirements, or Gary would say the architect's drawings. Then you get the architect's plans, or the as-designed representation. They have to transform that into the as-planned, the manufacturer call as-planned, or Gary would call the contractor's plans. Okay, now you have to build it. So you have the owner, you have the concepts, the designer, the logic, and the builder, the physics. And we were already using words, conceptual, logical, physical. So, so we were beginning to do the same thing without having any structure behind it. So then the manufacturing engineering people get the as planned. That's it. And I'll spare you the discussion of. I'm into it. I might as well tell you. In fact, I told this anecdote the other day. Lockheed built the first wide-bodied airplane, and Rolls-Royce was building the engines, and Rolls-Royce didn't deliver on schedule. Okay, so Lockheed delayed the delivery, but the Lockheed airplane, you guys remember, probably was a Lockheed 1011. It had 3 engines. It had 2 engines on the wings, an engine on the tail. The third engine on tail, the airflow came in through the engine. It was built on the top of the fuselage, and then it changed direction to go out. The exhaust go out the back of the airplane. So that was inefficient actually, but Lockheed did not deliver the airplane. But Douglas actually delivered the first wide-body airplane, which was a Douglas DC-10. You'll notice there are 3 engines. There are 2 on the wings and 1 on the tail. But they designed it so that the third engine is not sitting on the fuselage, it's sitting up on the tail. So the airflow went straight through through the engine. So it was a much more efficient design. But they couldn't build it that way, because the material strength, there was not enough material strength to hold it on the tail, to hold the weight of the engine and the stress of the engine driving the airplane. There's a lot of airplane that engine driving. So they couldn't build it the way they designed it. The as-designed P, the representation was, I would call row 3, the logical design of it was a good design, but the row 4, the physical implementation of that design, was different. Okay, you understand what's happening here. The technology constraint is different than the logical representation. Okay, you guys. The
Yeah, we
logical
got it.
model is one thing, and the physical database design is a different thing. Okay, so you have the engineering bill of materials and the manufacturing engineering bill of materials. It's the same issue. Okay, so anyway, so I was just trying to figure out how do you formalize this and to help people begin to do the work. Now, in any case, so I became, I actually believed it, see. I'd say, oh my gosh, look at this. It's the same thing here. So, we just have to exploit the metaphorical correlation. So I really got interested in it, and I cared about it. So I basically continued to work with it. To this day, I have to say one, forgive me, Lorne, you're never going to ask me to do an interview again.
It's very easy, actually.
So,
Probably too easy.
I'll make this observation. I've been working on this for 40 years. Okay. Well, 35 or 40, it's around 40. And there was some folks out of Pretoria University who, in collaboration with there's a university in Belgium and another one in Canada, they wrote a document. It was based on the future of the enterprise. And they built the argument around my framework, okay? And they wanted to get the thing published in an academic journal. And so therefore, it has to be peer-reviewed. So one of the peer reviewers, of course you don't know who they are, right? One of the peer reviewers said, well, you spent too much time talking about the Zachman framework because we already know everything about that. Okay, so I thought about this for a minute. I thought, geez, that's really interesting. I've been thinking about this for 40 years. I don't know very much about it myself, So, okay, we're beginning to learn something here. We're talking about complicated issues here. I'm watching Len Feshkins talking about this today. He was really being honest. We don't even know how to bound the problem. We're too busy to say, hey, we don't have time to really understand that. We got to write the code, So we get very, we don't think actual work is taking place until code is running. Well, maybe, if you're designing airplanes, the design of the airplane is not indirect. And you don't have to have parts coming out of lathes and presses and so on before actual work is perceived. No. The actual creation of the architectural constructs are as much of the work as the actual production of the parts. So, we think until you see the system running, no work is taking place. So we don't have time to, think about it. We get driven off the short-term end of the spectrum, to try to get parts created. So that's raising another issue. So we, the IT people, we've been manufacturing the enterprise for the last 70 years or 65 or 70 years. The system is the enterprise. People used to get upset with me and say, the system is the enterprise. Well, they say, oh, the system it supports the enterprise. Wrong. The system is the enterprise. You've been replacing the people of the enterprise with systems for the last, 70 years or so. What were those people doing? Weren't they the enterprise? If they weren't the enterprise, you shouldn't have bothered replacing them with systems. Basically, the system is now, you made the system the enterprise. If there's any question in your mind whether the system is the enterprise or not, turn the system off for 15 or 20 minutes. The place will come to a screeching halt. We're manufacturing the enterprise, but it was never engineered. We're manufacturing parts without having the engineering done. So the parts, we manufactured a bunch of parts. The parts don't fit together. Oh, okay. Well, what do you do if you manufacture a bunch of parts, the parts don't fit together? Hey, scrap and rework. Throw that stuff away and start over again. There's no way to fix that problem after the fact. If you want the parts to fit together, you have to engineer them to fit together before you manufacture them. Okay, so it becomes once you have some ontological structure. Forgot me using a word now I haven't used before, but if you don't have that, it's hard to figure these things out. We're living in the implementation domain before we understand what the laws of nature are, basically. But it's really encouraging these days. I'm really encouraged because there's a lot of really good things going on.
No, that's great. So John, this guy Dewey and your early framework, what's changed? Because you released the first framework about 30 years ago. What's been the significant changes since that now and then for you? What have you had to change in terms of the way you look at things?
Actually, I'll tell you what, the framework hasn't changed. Actually, the framework has been around for thousands of years. Okay. Now, some of you guys have just been with me here the other day, and some of you guys have heard me talk about this years ago, but some people, Mike Miller has heard me talk about this for 30 years and so himself. But the fundamental classification. Wait a minute, I better say this. The way humanity deals with complexity is classification. You have to deal with smaller parts. Okay, so there's more than one way to classify things. You can classify them in a hierarchy or a taxonomy. Usually the dictionary will tell you a taxonomy is just a classification. It doesn't say one-dimensional classification, but when people say taxonomy, they think about the Linnaean biological taxonomy, which is a hierarchy. So you can classify things in a hierarchy. You can decompose it into smaller pieces. Okay, that's really good for manufacturing. See, because if you decompose it, the smaller the pieces are you decompose it into, the faster and cheaper it is to build a piece. You can make it really agile if you want to. Get down to a few lines of code. So that's a single-dimensional decomposition. Fundamental, that's good for manufacturing. It's no good for engineering because what you're doing is you're disintegrating the object. It's good for analysis. It goes back to I lose the name. The Wealth of Nations, which is Adam Smith. You break it up in smaller pieces, then you can deal with the pieces. So it's really good for implementation purposes. But what you've done is you denormalize everything. The same content is showing up on all the different nodes at the bottom of the tree, okay? So it's denormalized. The pieces don't fit together. So they're good. It's good for manufacturing, but it's not any good for engineering. Engineering, you want to engineer it so the pieces fit together. So if you want to get the pieces to fit together, you need a two-dimensional schema. Two-dimensional schema to normalize things. Okay, so now you got Ted Codd is floating around with a relational model. In fact, the word normalization was not in our vocabulary till Ted Codd basically came up with the relational model. Okay, now you can normalize everything. What you want to do is you want to have the minimum possible set. You don't want any redundancy, reoccurrence. That's anathema from an engineering standpoint. So in order to engineer something, you only want to look at one type of fact at a time, and you have to see the total set, so you can get rid of the reoccurring concepts. Because if you have a reoccurring concept, now you have a discontinuity potential. If you have the reoccurring concept, the same concept in there more than one time, it gets out of sync. Now you got a problem. Okay, so you have to have some middle stuff in there, or an MBA within a Excel spreadsheet that keeps track. This is really that. So that now your entropy in the enterprise increases. Your general administrative costs will increase because you get discontinuity. So you get rid of the reoccurring concepts, but you have to have a two-dimensional schema. Okay, but now this is a classification, but it's a two-dimensional classification. So you have one fact in one place, basically. You only have one kind of fact. They say fact type, basically, in one place. So that's good for engineering. It's not good for manufacturing because now you're looking at the whole thing. Okay, so therefore, you have to look at the total set. Now, from a practical standpoint, from a methodological standpoint, you don't have to do all this, all the work. You only have to do as much as required to address a specific issue at a specific point in time. Okay, so A lot of people, I've always said this. I never said you had to stop the music for 15 or 20 years and build a bunch of models. I never said that. But people hear me say that every time I make a presentation. Well, John Zachman says we'll stop the music for 15 or 20 years and build a bunch of models. We're not doing any work, no, nothing is getting built. I never said that at all. Okay, so you only have to build the subset that is required for some specific issue. And boy, in the last 5 years, I really learned a lot about this. I would start with the CEO's problem. See, if you start with the application, you're going to build an implementation. So the application is going to implement something that may or may not have anything to do with what the CEO's problem is. In fact, the last 30 years or so, the CEO surveys will say that, the top issues that IT has to deal with is alignment. It's been in the top 10 issues for the last 30 years. The last 3 years have been in the top 2 or 3 issues. They basically, there's not a connection between whatever the systems are we're building and whatever the CEO is thinking about. So what you ought to do is you ought to start with what the CEO is thinking about. Because right now we don't have access typically to the CEO, but that's where you probably ought to start. So then you have to start with what the CEO's issue is, and you parse out the single variable, what I call primitive components, and sort those into the framework structure. You just say, are there any inventories that are causing this problem? Is it an inventory concept? Or is it the inventory logic? Or is it the inventory physics? Or is it a tooling configuration? What is the problem here? Is there a process that's causing the problem? Is it a process concept? Is it the process logic? Is it the process physics? Is it process tooling? Is there a location issue here? Is it process location concept? You understand what I'm doing? I mean, this is not hard. But you just have to take whatever the chief is talking about and then sort into the ontological structure. My framework turns out to be an ontology. I didn't even know that that was only about 10 years ago. Somebody explained that to me. So you just sort of, you only have to populate whatever cells of the framework that are relevant to this problem. Okay, but then what you have to do is, in order to diagnose the problem, the CEO is telling you the symptom of the problem. He's not telling you what the problem is. Okay, telling you the symptom. Hey, we have a regulatory issue here, or we're not making enough money, or the customers are not buying the product, or we're not growing, or it's inefficient, or whatever. It's telling you the symptoms. So you got to figure out what the primitive components are. Then you have to understand what the relationship is. You say, well, is this thing dependent upon that? And is this dependent upon that? Is this dependent upon this? Is this dependent upon this? It's just a binary models, 2 things at a time. Is this hard to do? No, this is trivial. And if you build just the binary models, you can touch on it, you can do impact analysis now. You touch this, and here's all the things that are impacted. So then you can go look and see if any one of those things are actually causing the problem or not. You can fix those things. So you don't have to build all the models. You just have to start with what the CEO thinks. And by the way, if you can solve the CEO's problem, you have the value of architecture issue goes away because the CEO is happy. And he says, whoa, that is really good. By the way, I got another problem. There's not going to be an end to these, okay? And he's got another one. So you just begin iteratively and incrementally populating out little by little, problem by problem over time, and someday, hopefully, you'll have it all populated. Probably you'll never get it all populated.
Perhaps you'll be the CEO.
Yeah, right there.